Hello everyone, this is Rakesh from Bodhee Prep. I hope you have gone through the previous videos on number system. This is the continuation of the same of basics of number system. And for those who are watching this on the YouTube or some other social media platform, let me tell you that we run online CAT coaching and you'll be finding the details in the description, link in the description. You can click the link and you'll get the details about the same, right? So let's start the sessions, and in today's session, we'll be discussing primarily on perfect squares. The entire session will be purely on perfect squares. This is the most important but yet very much neglected topic. As and when we are approaching to the upcoming videos, we'll be getting into the details of the numbers. So what are perfect squares? We all know that if I take any number, say if I take a number 3, and if I do the square of it, I'll be getting another number which is 9. So this 9 is called a perfect square. Why? Because 9 is a square of a number which is a integer, right? So perfect square are what numbers? The square of any integer, the result becomes the perfect square, right? And needless to say that whether the integer is positive or negative, the perfect square will always be positive, right? This is the basic property of perfect square. For example, instead of 3, if I take minus 3 whole square, this simply means what? Minus 3 is multiplied with minus 3. Now minus into minus is what? Plus. So overall the answer would be plus with plus sign, and 3 into 3 makes it 9. Plus 9 effectively means 9, right? So since both are positive, again we'll be getting the positive number. If both are negative, we'll be getting negative into negative positive number. So perfect squares are always positive integers, right? And these are the square of sum of the integers, right? So if I want to figure out that which is the smallest perfect square, then that is 0, because 0 is square of 0. If I take a square of 0, again I'll be getting 0. So 0 is the smallest perfect square. Can we have 1 as the perfect square? Yes, because 1 square is also 1. So this is a perfect square. This is also a perfect square, right? But 2 is not a perfect square, because we can't have any number, any integer wherein we square the same. For example, I can't have an integer x for which x square is equal to 2. This will never be an integer. This will be what? X will be what? Under root of 2, which is a irrational number, right? Perfect square would be positive integers. Sorry, non-negative integer, I would say. Perfect square will always be non-negative integers. Since they are non-negative integers, obviously any chance of being irrational is ruled out, right? Because integers are all rational numbers. Fine. So the next perfect square would be 4, and that is because I'll be getting it by squaring 2, either 2 or minus 2, right? So I'm just ignoring the negative numbers right now, because in both the cases the result would be same, right? Similarly, 3 square would be 9. So the next perfect square on writing all the numbers right from 0 to till say infinity, next perfect square after 4 would be 9. This is a square of 3. Similarly, 4 square 16. 16 is the next perfect square. Then 5 square 25. Next perfect square, so on and so forth. So we can see that there are many perfect square which we can generate. Just we need some number which is should be integer, and square it. We'll be getting the result. And the result is a perfect square, right? So what all things we need to understand about perfect square? We need to understand few properties of perfect square which can be used to solve some of the questions, right? Apart from that, at times we need to quickly square some of the numbers, right? At times we need quickly to get the square of some of the numbers. So for that, the prerequisite thing is that one should have learned by heart square of number from 1 to 25. If you know the square of numbers which are from 1 to 25, then mostly you can get the square of any numbers, right? Practically you can get the square of any number, but we'll restrict ourselves to finding the square of first 125 numbers, right? So I'll give you the trick wherein you can find the square of any number from 1 to 125, provided you know the square of first 25 numbers. Now these are easy. Some of the numbers you might not be remembering, but most of it you will be remembering. So let us just list down those perfect squares from 1 to 25. So 1 square is 1, 2 square is 4 easy, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100, right? Then 11 square is 121, 12 square would be 144, 13 square is 169, 14 square is 194, 15 square is 225. 16 square is 256. 17 square is 289. 18 square is 324. 19 square is 361. 20 square is 400. Right? Then 21 square is it would be 441. 22 square would be 484. 23 square would be 529. 24 square would be 576, right? And 25 square is 625. So these are the square which you have to remember. I hope that you might be knowing more than half of it. Some of these squares, if you are not, if you don't know, then definitely you can just learn them. If you know this thing, then definitely you can find the square of any number, as I said, from 1 to 125. Right? So from 1 to 25, obviously you have to remember them. Let us find the square which are close to 100. Close to 100, when I say close to 100, that means when I deduct that number from 100, the difference, the absolute difference would be between 1 to 25. Right? For example, let us take those numbers which are above 100 or numbers which are between 100 and 125. Of course, square of 100 is immaterial. It would be 10,000. We all know. What would be the square of 101? So the trick here is that you compare 101 with the base number, which is 100. 100 becomes the base because this number is close to 100, right? So you'll be getting the difference, which is 1. So you have to take the square of this difference. What is the square of this difference? 1 itself. But we have to write in 2 digits, right? So if I have a single digit number, say 3, and I want to write in the form of 2 digit, I should be taking the help of 0. 0, 3 in value wise is 3 only. But for the purpose of writing it as a 2 digit, I can say 0, 3 is a 2 digit number starting with 0. Technically, I'm saying whatever I'm saying is wrong mathematically. But for the purpose of using this trick, we can assume that 0, 3 has 2 digits. The value wise, the number is 3. So similarly here, if the number is 1, the square, we have to take the square of the difference. So square of 1 is 1, but we'll be writing 0, 1. Next thing is that since this number is 1 more than the 100, what you have to do is that you have to add again 1, the difference itself, to the number, which comes out to be what? 102. This number you have to attach here in front of the first 2 digit which we have written. Whatever comes, this becomes the square of 101. Right? Now I'll ask you to please verify using the calculator or multiplication. So I'm doing the same. 101 multiplied by 101, it comes out to be 10201. Right? This is the trick. So let us try some other just a second. For some other number, let us try the same. So the next number, let us take, I'm just randomly taking the number, say 107, right? You have to find the square. So 107 is 7 more than the base 100. So the square of 7 is what? 49, which itself is a 2-digit number. So 49 will be at the last, will become the last 2 digit of the square. Then again, since it is 7 more, we have to again increase the number by the difference, which comes out to be what? 114. So we have to attach 114 here. This becomes the square of 107. Again, just for the verification, we'll be squaring 107, multiplying with itself. I'll be getting 11449. Right? You can check on your own, right? You can check using calculator or whatever method you want to use. You can check. Next is, let us assume that the number is 113. This number is 13 more than the 100. So what is the square of 13? Square of 13 is what? 169. Now in this case, I'm getting 3-digit number, right? 169 is a 3-digit number, but we have to only write last 2 digit. So we'll be keeping 69, or we'll be writing 69, and we'll keep 1 as carry forward. What is the next step? Next step is that we have to increase the number by the same quantity with which it is more than 100. So the sum would be what? 126. Now what about carry? Usually what is carry? Carry forward means we have to add it to the next. So the carry forward will be added. So overall it should be 127, and this 127 should be attached here. So 113 multiplied to itself will give me 12769, right? So from these three examples, what we understood is that if the square is 2-digit, then we don't have to do any kind of adjustment. But if the square is single digit, then we have to take the help of 0 to make it 2-digit, right? And if the square exceeds 2-digit, then we have to retain 2-digit at the last, and the 100th place digit will be carry forward. That will be added in the subsequent columns, right? So let us take few more examples. Say 100 and let me take 117 square. This is 17 more than 100, so 17 square is 289. So I'll be writing 89. 17 square is 289. So I'll be writing the last two digit. I'll retain this as carry forward. Next thing is 117 should be increased by 17, right? So this comes out to be 134 plus this carry forward will make it 136. So we'll be writing 136.89. So again, for the final purpose, I'll be checking it, which is 136.89. So this becomes the square of this number, right? Let us take the number 124 square. In this case, 24 square is what? What is 24 square? This is 576. So we'll be retaining 76. 5 would be carry forward. We'll be adding 24 here. So it will make it 148 plus 5 will make it 153. So much of the calculation can be done mentally also. Straight away in one line, you can write the square of any number if you just remember this trick. The trick is compare with 100. Whatever is the excess, take the square of it, write in the last two digit. If there is carry forward, that will be added subsequently. We have to increase the number by the same difference. And if there is any carry, we have to add that as well. Right, guys? Fine. So let me give you a few examples or few exercises to do. Let us take 3 exercises and let's see that if you can do that. The first exercise, let us find the square of this. Let us find the square of this. Let us find the square of this, right? Please pause the video, take your time and get the square of this number. After you are done, you can just resume the video to check your answers, right? I'll take a pause. Okay, I believe that you must have done that. This is 19 more than 100. So 19 square is how much? 361. 19 square is 361, right? Let me cross verify. This is actually that. Yes. So we'll be retaining 61 and 3 will be carry forward. Again, 119 should be increased by 19 plus we have to add the carry, right? So 119, we have to add 19 plus we have to add the carry forward, which is 141. So 141 will be written here and that should be the square. 14161 will be the square of 119. Similarly, this square of 2, we'll be using it 0 to make it 04, right? Again, we'll be adding 2. So it will become 102 plus 2. So 10404. What is the square of 23? It is 529. So we'll be retaining 29. 5 would be carry. 123 plus 23 is 146 plus 5 make it 151. So it will be 15129. Right? I hope you two got the same square, right? Let me check for 123. This comes up to be, yes, 15129. So I hope you have got the idea that if the number is above 100, close to 25, then we can use this, right? Now, what about the number which are below 100 but very close to 100? So I'm taking numbers which are between 75 to 100, right? If I take the difference, that difference is in absolute term is within the limit of 25. For example, if I want the square of 97. Now this number 97 compared to 100 is 3 less, right? So what we'll be doing is that we'll be getting the square of this difference. So the square of -3 is what? 9. We have to write 2 digit. So I'll be writing 09. Again, the next thing is that we have to add the difference. The difference here is -3. The difference here is -3. So instead of effectively adding 3, we are deducting 3. So this comes out to be 94. So we'll just attach 94 here and this becomes the square of 97. Right? If the number is less than 100, the difference would be what? Negative, right? Next is say 93 square. This 93 is 7 less than 100. So -7 square is 49. So we'll be writing 49. Again, we'll take 7 out of this. So 93. If I deduct 7 out of this, I'll be getting 86. So I'll be writing 86 here. Correct? Now let us take 81 square. Now 81 is 19 less than 100. So -19 whole square is how much? it will be 361. So I'll be retaining 61. Next step is what? 81. We have to deduct minus 19. But this 3 is carry forward. So we'll be adding plus 3. So let us do this calculation. So 81 minus 19 plus 3. Carry forward will always be added, right? Carry forward will always be added. Whether the deviation is plus or whether the deviation is positive, negative, it doesn't matter, right? So this comes out to be 65. So 6561 becomes the square. You can just check that 81 into 81 is 6561. So this becomes the square of 81, right? Similarly, he says 79 square. So for 79, the difference is 21. So 21 square minus 21 square is 441. So 41 will be written here. 4 is carry forward. Next is 79 minus 21 plus the difference, plus the carry forward 4. So 79 minus 21 plus 4 will give me 62. So 62 will be written here, and 6241 becomes the square of 79. Right? So I hope you can now find square of any number which is between 75 to 125. The only thing you have to do is that whether the difference is negative or positive, depending upon that, you have to add it or delete from the original number for which we are finding the square. Right? Okay. Next thing is, how about those numbers which are way less than 100, right? The division or the difference is exceeding 25. In that case, what happens is that we change the base from 100 to 50, right? We change the base from 100 to 50, right? So in this case, for example, any number which is between 50 to 75, for example, right? Above 50, but very much less than 100, so that the difference when we try to figure out from 100, for example, if I want to find the square of 71, if I want to take the difference from 100, then definitely that difference is 29. I'm assuming that I don't know what is the square of 29, right? I just assume that I know the square from 1 to 25. So 29 is beyond that. In that case, rather than comparing it with 100, we'll be comparing it with 50. We'll change the base from 100 to 50, right? So the process also changes slightly. Let's see what happens. Let us assume that we want to find the square of 54. We want to find the square of 54. Comparing it with 50, the difference is 4, positive 4. So 4 square is what? 16 that we have written. Now this plus 4 will not be added in the base. There is a change. The change is that every time the addition or deletion has to be done with 25. Half of the base, because we have changed the base from 100 to 50. So we have done half of it. So every plus or minus have to be done from half of the base, right? That's the logic. So even if you don't remember the logic, just remember the rule. Every plus and minus we have to do on 25. So this is plus 4 will be added on 25. This will be 29. So 29 will be attached here. So 29, we can just check. 54 into 54 is 2916. This becomes the square of 54. Right? Let me give you some couple of more examples. Say 59 square. It is 9 more compared to 50. So it will be 81. So 9 more will be added on 25, not on 50. In case of 100, it was added only on 50, only on 100. But in this case, every addition and subsequently every deletion has to be done on 25, right? So this comes out to be 34. So 34 will be attached here, and you can check that 59 multiplied by 59 is 3481, right? How about 63? 63 is 13 more than 50. This is close to 50, right? 13 more than 50. So 13 square is how much? 169. So 69 will be written at the last. 1 will be carry forward. Next thing is 25. We have to add 13 plus the carry forward. So 25 plus 14 overall is 39. So 3969 becomes the square of 63. Right? So this is how you can find square of all the numbers from 50 to 75. Let me give you some examples, some exercise. Let us take the exercise of finding the square of, say, 71. Right? Second, finding the square of 52. Third, finding the square of 64. Right? Just pause the video and try it. Okay. So let's check whether you have got it right or not. Now 71 compared to 50, it is 21 more, right? So 21 more in the sense, square of 21 is 441. So we'll be writing 41 at the last, right? 4 would be carry forward. Again, 25 plus 21 plus 4, right? So this makes it 50. So 5041. You can check. 71 into 71 is 5041. Similarly, this is 2 more. So obviously it is 0, 4. 2 will be added to 25 to make it 27, right? This is 14 more. 14 more is 194. So 94 will be written, 1 is carry. 14 plus 1, that is 15, will be added to 25, will make it 40. So 4064. Let me just check whether it is same or not. Yes, it is 4096, guys. 96, right? Please check. 194. Okay, I made a mistake, guys. Please note that 14 square is 196, not 194, right? If I made it mistake, please correct it. The 14 square is 196. Okay. So I hope you have got the idea that any number between 50 to 75 can be done in this way, right? Next is the number which are less than 50 but about 25. Less than 50 but about 25. In that case, the same logic will be applied. Only thing is that the division would be in negative. Say we want to find the square of 47. This is 3 less than 50. So minus 3 whole square comes out to be 9. We will be writing 0, 9. Next thing is in 25, from 25 we have to deduct 3. The difference, which comes out to be 22. So 2209, right? 43 into 43 is 47. No? We add to 47 into 47 is 2209, right? Similarly, for 42 square, this is 8 less than 50. So 8 square is 64, right? Next thing is 25 minus 8. So 25 minus 8 is 17. So 1764 is the right answer, right? 42 square is 1764. So I hope you are getting the idea, right? So let us do one few exercises. You have to find the square of 39. You have to find the square of 35. You have to find the square of, say, it's less than 50 we want to find, right? So 41, right? Please try. Okay. So for 39, what we have to do is that comparing with 50, it is 11 less. So 11 square is 121. So we'll be writing 21. 1 is carry forward, right? Next is 25 minus 11 plus 1. So effectively, we are deducting 10 from 50 and 10 from 25. So it comes out to be 15. So 39 into 39 is 1521, right? Similarly, for 35, the difference is 15. So 15 square is what? 256. So we'll be writing 225. So 225 will be 25, correct? And 2 is carry forward. Then from 25, we have to deduct 15 and we have to add 2. So 25 minus 15 plus 2 comes out to be 12. So it is 1225. For 41, it is 9 less, so it will be 81. 9 square is 81. Again, from 25, we have to deduct 9, which comes out to be 16. So it is 1681. We can check. 41 into 41 is 1681. So I hope now you can find a square of any number which is between 25 to 50, right? In the previous case, anything from 50 to 75. Before that, anything from 75 to 100, right? And we started with any number from 100 to 125. Correct? 100 to 125. So you can see that just by knowing the square of first 25 numbers, we can get the square of the next 100 numbers. This logic can also be extended for larger number, but I think that is beyond the scope of this basic fundamental session. So I'm just leaving that, right? We might touch this when we are doing some complex questions, right? Okay, the next thing is some basic properties of some very, very important properties of perfect squares, right? There are various properties. I'll just be touching those properties which are elementary, right? And as and when we move forward, when required, I'll be giving you more about the properties on perfect squares. So the very first property is that I've written those basic properties. The first property is that the perfect square always ends with even number of zeros, right? For example, 100 is a perfect square. It is having 2 zeros at the end, right? 1000 is not a perfect square. Why so? Because it has 3 zeros. So it will never be a perfect square. We will not be finding any number for which the square is 1000. That's the first thing, which is basic observation. Next is the unit digit will always be 1, 4, 5, 6, or 9. The unit digit will always be 1, 4, 5, 6, or 9. Please remember that every number whose unit digit is 1 is not a perfect square. But every perfect square, the unit digit, if it is 0, it will have even number of zeros at the end. Otherwise, the unit digit will be either 1, 4, 5, 6, or 9. That means any number which ends with 2, 3, 7, and 8, we can be very sure, no matter how big this number is, we are sure that this is not a perfect square, right? We can prove it, but the proof itself is complicated. What I'll suggest is that you can just do these things or remember these things by observation. What you have to do is that write few perfect squares, starting few, say 10 perfect square. So 10 perfect square is 1, then 4, then 9, and then 4 square is 16, then 25, then 36, then 49, then this is 7 square, na? 64, then 81, then 100. You'll find that none of these numbers ends with 2, 3, 7, and 8. So whenever you want to recall that there were some properties of perfect square related to unit digit, you can just write down the first 10 numbers. From there, you'll be finding that 2, 3, 7, and 8 cannot be the unit digit of any perfect square, right? Now, what kind of question can be asked? Very simple question can be asked. It can say that which of the following is perfect square. So the very first thing is that it can return 1, 7, 3, 4, 3, 2, 8. The next is 7, 3, 1, 4, 9, 8, 4. The third one is 7, 3, 3, 1, 4, 5, 6, 7. The seventh is 1, 1, 4, 3, 9, 8, 1, 7, 3. I'm not saying that I'm randomly writing it, but I can solve this question by elimination. What? These cannot be the unit digit. So from here, I can say that these three will surely not be the perfect square. But this is a question wherein one would be a right answer. So I'll say that option 2 is the right answer. I'm not saying that 7, 3, 1, 4, 9, 8, 4 is a perfect square. I've randomly written it. I'm just saying that how these properties can be applied to eliminate the options. Getting the idea? So if you don't know this particular property, then definitely it's going to be Herculean task to figure out that which one is the perfect square. These numbers are having 6 digit, 7 digit, 8 digit, right? Even calculator will be, it will be difficult to use the calculator to get the right answer instantaneously, right? Okay, what is the next property? So the next property is, this is the first property. Next property is that the digital sum of perfect square is always 1, 4, 7, and 9. So first of all, let us understand what is digital sum. In fact, let me just retain this. I might be needing it. Second is digital sum. Digital sum is always 1, 4, 7, or 9. Now, what is digital sum? If I write any number, 7, 8, 3. If I want to take the sum of digits, sum of digit would be what? 7 plus 8 plus 3, right? So 7 plus 8 is 15, plus 3 is what? 18. So this becomes the sum of digit. But digital sum is what? We have to again follow the process of sum of digit till we get a single digit number for any number. So for this, if I want to find the digital sum, I'll take the sum of digit and I'll identify that this is a 2-digit number. So again, I'll start the same process of finding the digital sum of this result. So again, digital sum of this result will give me 9, which is a single digit number. So now this 9 becomes the digital sum of 7, 8, 3, right? So we have to keep on doing the sum of digit till we get the single digit number, right? So digital sum of perfect square is always 1, 4, 7, or 9. Again, any number whose digital sum is 1, 4, 7, or 9 may not be perfect square. But for perfect square, this is necessary that the digital sum is 1, 4, 7, or 9. Right? For example, in this case also, only we can say that the digital sum is 1, 4, 9. In this case, we can see that this is 7, right? In this case also it is 7. In this case, it is 9. In this case, it is how much? 4 plus 9 will make it 13. Then 1 plus 4 will make it, 1 plus 3 will make it 4. This is 6 plus 4 is 10. 1 plus 0 will make it 1. This will make it 9. This itself will make it 1. So you can just check. We are not getting any other digit other than 1, 4, 7 or 9. Right? You can check for any larger perfect square also. Take it as a homework. Now, what kind of question we can have from this? The question could be, say, if I have a number which has used digit 1 only once, 2 twice, 3 thrice, and digit 4 times, right? I'm just generating one good question. Just see. So it will have a 10-digit number. We can have a different variations of it, right? I'm writing some of those numbers. So one number itself is this. The other number would be, say, 2, 2, 3, 3, 3, 1, 4, 4, 4. The third is 3, 2, 2, 4, 4, 1, 3, 3, 4, 4. The fourth one is 3, 1, 3, 3, 4, 4, 4, 4, 2. We have to find that which of the following or how many of them are perfect square, right? Again, it's a very difficult task if you don't use the logic of digital sum, right? If you observe that these numbers contain 1 only once, 2 twice, 3 thrice, and 4 times. Let us try to figure out the digital sum. The digital sum of all these numbers will always be same because it is immaterial. Which digit has been added first and which digit added last, it doesn't matter. The overall sum will always remain the same. So let us try to figure out the digital sum of these 10 digits, right? So this will make it 5, right? I'm just writing 5. This will make it 9. This will make it 16. Again, we have to add them. So 5 plus 9 is 14. Plus we have to make 16, so it comes out to be 30. Again, the digital sum would be 3. So can I say digital sum in each of the cases 3? So for perfect square, the digital sum has to be this much. Anything between these among 1, 4, 7 or 9? In each of the case, the digital sum is 3. So what we can say that none of these numbers can be perfect square, no matter in what order you can arrange them. This is the power of properties. If you know the properties, you can apply the properties and instantaneously you'll be getting the right answer, right? So that's it for this video on perfect square. In the next video, we'll be touching another very important number, which is prime numbers.